This winter is very different to what we've done any previous winter. Usually we just do winter maintenance on the aircraft, overhaul the engines for the winter maintenance and make it ready for the taxi runs the following year. This winter is the first step towards making the aircraft airworthy. And that first step is to completely paint strip the aircraft, take as many components off it as you can, do a survey of the aircraft and the airframe to then create the work packs moving forwards to restoring the aircraft to an airworthy condition. So as you see NX611 today, she is in a position where she's almost ready for the repaint. Repaint of the aircraft starts next Monday, so we have a couple of days left to get her completely ready for the repaint. So she had all of the paint stripped off. What we found is she had about 4 layers of camouflage and black paint on her, and the roundels, which are the circles on the side of the aircraft, had about 10 layers of paint on. The company that did the paint strip and are doing the repaint for us is a company called Aviation. They're based in Maastricht in Holland, Alabama in America, and Dublin in Ireland. So a really huge international company. The reason, or the way they got involved with us here at East Kirkby is through one of the members of the centre called Armin Lloyd. He saw on eBay there was a batch load of gauges coming up for sale, which would have been correct for the Lancaster. He approached us to see if we wanted to buy them. Of course, we said we'd love for them for the centre, so he bought them for us and shipped them over. The person he bought them from questioned him, why on earth would you want all of these gauges, especially considering that there's a radioactive paint that's used on them as well, so it's not everyone that can own them. And he explained to the seller as to where they were coming and what they were going to be used for. The seller's name was a gentleman called Tim McDougall. And it turns out that he runs a company called Aviation who paint, strip and repaint aircraft. Tim got very interested in the project. It turns out that his father was a pilot on Lancasters during the Second World War, and he offered his help to see if there's anything he could do for us to further the project. We could of course think of something that he could do for us. About a year prior to that, we had a quote to completely paint, strip and repaint the aircraft, and it came in at £125,000. It looks like the work that Aviation are doing for us is going to come in at about £20,000. So it's a huge saving for the centre, and to which we're of course very grateful to Aviation. So they came in November, did a paint strip on the aircraft. They expected that to take about 7 days, whereas actually it took about 12. It takes about 5 or 6 days to paint strip a big jumbo jet, so you can see what trouble they had with it. The air was a little bit blue when they found how many layers of paint there were. Another problem they faced was the fact that not all the paint that was used was the same. So the paint strip that they got for the top coat didn't necessarily work very well on the coat underneath. So yeah, there's a good reason we closed the hangar for that period of time. It wasn't just a few. So it was a chemical paint strip they used, which basically took it off layer by layer, which was very interesting for us with the history of the aircraft, because we could see the different layers of squadron coats being removed layer upon layer, and also the nose art of the aircraft. We could see how it had changed over the period of time, from the swimsuit that was red to the black and white bikini that she wore later on. So straight back to the bare aluminium, that meant that we could really see the physical condition of the airframe, both the skin and all the rivets on her as well. From doing that, we've done a complete survey of the aircraft, which is all in paper form. That means that we can then give that survey to the CAA and say, this is where we stand at the moment, this is the condition of the aircraft, and this is what we're going to do moving forward towards making her airworthy. We did find quite a lot of surface corrosion on her. So you can see the aircraft is in 2 tones at the minute, in a dull silver and in a shiny silver. In the shiny areas, it's where we've run over the aircraft with these Rolock discs. These are basically polishing discs. They're kind of a plastic material with little teeth on them, which then agitate the surface and remove any surface corrosion. So I'll pass these around. You'll see some of them are particularly worn out. So I spread them around. Who can catch? So if you pass them around, have a look at them, they actually kind of polish the surface rather than actually damaging it. So they take off any bad metal and leave the good metal underneath. You'll see quite a few areas have been done. We found the majority of surface corrosion really was around rivet heads along the rivet lines. That's why it's kind of in the shape that it is. That's mainly because really when you put a rivet in, it slightly not damages the surface of the metal, but it allows corrosion to begin. The worst areas of corrosion on the aircraft are the underneath of the wings. You'll see above your heads the tank panels themselves have been cleaned in a different method, but underneath the wings there's quite a lot of corrosion that's been removed there. A couple of new panel skins as well, just behind the undercarriage there. The same on the starboard side. We think the worst corrosion under the wings is mainly because of the aircraft sitting over grass in periods of its life. When an aircraft sits on grass, the bottom never really dries out. So the moisture rises from the grass, hits the wing, drops, hits the grass, and so on and so forth. Whereas obviously the top skins dry out with the sun and the weather on them. We've also found that corrosion-wise behind the engines has been the worst. When the aircraft flew in the 1950s and 60s, it flew with a white paint with black lines behind the engines. And the worst corrosion we found on the wings is directly where that black paint was. Even to such an extent that on the number 4 engine, starboard side, the corrosion finished in a dead straight line where that black paint finished. So we're not sure if the paint itself reacted with the aluminium or if the exhaust fumes and deposits reacted with the paint, which then reacted with the aluminium. But it's certainly tied in somehow. So the removal of the corrosion took us 3.5 weeks, 4 weeks, something like that. And it's just a very tedious, laborious job with these row-lock discs. When you consider the wing area of a Lancaster alone is 4,000 square feet, and with the fuselage as well. And these discs are only a couple of inches in diameter, so it was a long time. We found that it really tested our pneumatic system, compressed air system, because the amount of air that we were using all at the same time. Generally, we haven't really found any two major problems. What it's really highlighted to us is that we do really need to drill down to taking the aircraft apart in its component pieces, and then overhauling it effectively a piece at a time and putting it back together again. The fins, so the vertical parts of the tailplane there, you'll see there's a light fabric material, seconite, over the leading edge. Behind that is a wooden leading edge, so it's a kind of mahogany, I think it is, which forms the shape of effectively the D shape of the fin. With that being wood over the time, of course, with the humidity when it was operating out towards Australia and May and all those kinds of areas, and also with just the length of time the aircraft's been together, that wood has begun to rot. Some of the screws that hold the wood and the metal together are coming loose because the wood's really deteriorating. So the wood is in the leading edges of the fins and also the tips of the wing tips as well. There's a wing tip just behind you, just on the trestle there, and you'll see that the tip of that's had the same treatment. The fins are probably the thing we're going to do next year, so they'll come apart on jigs, be completely stripped apart, everything inside examined and renewed where needed. There's a modification put in place to replace that mahogany with a metal leading edge, so that's something that we'll be looking at doing next year, sealing it all up, bolting it back on. So that's basically how we're going to be doing this aircraft. It's piece by piece, package by package. Another thing that's going to happen is, possibly not next year but the year after, we're going to be doing parts of the fuselage. So tail turret through to the transportation joint at the main plane there. That will come apart from the aircraft, be dropped down, completely paint stripped inside. Any rivets that need replacing will be done, any repair work that needs to be done, lifted back up, bolted back onto the aircraft. So the way we're doing this is in a series of years, part by part. That's mainly because we have to taxi the aircraft during the summer period. So winter period we do the work, summer period we taxi to raise the income to then spend on the aircraft during the winter. The whole project's looking like it's going to cost about £3.5 to £4 million, and that could take 5 years, 6 years, 7 years, 10 years, depending on how long it takes to do these individual parts. All of the funds spent on the aircraft is raised by the operating of the centre, so good people as yourselves coming to a day at the centre paying your admission fee, that goes towards restoring the aircraft. Also those that have a taxi ride on board the Lancaster, that all goes towards restoring the aircraft as well. We don't get any tax relief, we don't get any external funding, it is purely the operating of the centre that restores this aircraft. So thank you very much for joining us, paying your little dues as you come in. It all goes towards making this aircraft the best possible condition it can be in. So various things we've done to the aircraft this winter, as well as the survey, is to replace parts of the aircraft that we've needed to. What I'm going to show you now is anchor nut strip. Anchor nut strip was originally steel, and it was placed in areas where you screw panels together. So if you look underneath the port wing beside the undercarriage, there's a gap there that's about 8 inches wide. That's where the outer wing attaches to the main plane, central main plane of the aircraft. So you'll see the spar bolts in there. That is covered up by what they call a fillet panel. Those fillet panels just bolt up over that gap all the way around to seal it up. Those fillet panels are bolted through anchor nut strip. Now, anchor nut strip, as I say, is steel, so it corrodes over time, so we've had to replace all the anchor nut strip on the aircraft. We ordered new anchor nut strip in 2016. It took about 22 weeks lead time. We ordered 111 lengths of 6 foot length, and it was about £12,500 for the new strip. So I'm going to pass this round so you can see it, as you see the old stuff compared to the new stuff. It all has to be made in America and shipped over. Why they don't make it in this country, I don't know. But yeah, so that's all been replaced where the fillet panels are, both between the main plane and the outer main plane, and also where there's fillet panels just being fitted here between the fuselage and the trailing edge. It also fits around the number 1 fuel tank bays, and it will also be put around the number 2 and the number 3 fuel tank bays as well. And that basically puts a bolt, or a screw as it's referred to aviation terms, every inch. Avro seem to like their inch spacing, so wherever you go on the aircraft, the rivets are either an inch or every half inch, and all the screws are every inch. I think someone was lazy. I don't think there's really a method to it, that someone was lazy as to working it out really. But yeah, as you see, it's all inches or half inch spacings. One of the things we've found that we have to do to this aircraft is replace the rivets on the main plane. So each wing, from fuselage through to where the wingtip attaches, between the wing spars. So basically where the undercarriage opening is there, that's the space between the spars. So that's wingtip to wingtip. That's the wing. Yeah, the wingspan is 102 feet, so it's about 82 feet all the way across the main plane. So those rivets are every inch. All those rivets need to be replaced, and the spacings between the rivet lines is about 6 inches. So anybody who's good at maths can work out how many rivets there are. There's a few. But in order to replace those rivets on the tops of the wings, we've got to de-skin the bottom of the wing. It's a solid rivet used in top, to which you've got to reaction both sides of it, and then you pop rivet the skin underneath. So at some point we're going to be removing the wings off the aircraft. They'll go onto jigs to make sure they don't move when we take the skins off. The bottom skins removed, top skins, rivets will be drilled out and replaced, and the bottom skins put back on. That also means that we get a good chance to have a look all inside the wings, any internal corrosion there may be, any tears, any cracks, anything like that, before we seal them back up. So the aircraft, when it's finished, every inch of it will have been inspected and looked at. That's pleased the CAA immensely. What they don't like is someone restoring an aircraft, getting it on the end of the runway for test run, and then saying to the CAA, hey, look what we've done, we're finished, come and have a look. They like to see it right from the get-go through to completion. So the CAA came to see us about a fortnight ago, maybe even 3 weeks ago now, had a look at the airframe as it is now, have a look at what we're doing, before they give us a rubber stamp for our approval to do the restoration on the aircraft. What we've done this year is really year 0 on the process. Next year will be year 1, when we have all of our approvals in place, have all the work packs in place to continue restoration of the aircraft. One of the big changes for this winter is we've started working to our A823 approval, which is basically the approval to be able to do the work on the aircraft. That has introduced an awful lot more paperwork, so everything you do needs to have a work pack arranged with it, telling you how to do it, and be signed off to say it's completed. That's meant that we've had 1.5 engineers working solidly on paperwork all the way through this winter. So they've not been able to go on the aircraft, they've been solidly on paperwork. Our team's been about 8 people through this winter. Of course, as I said, 1.5 of those is on paperwork, raising the work packs, looking for drawings, working everything out and ordering everything required to do the work. So about 6.5 people continuous on the aircraft every week from the start of November through to now, and that's got us in a position now where the aircraft's ready for the repaint. All the components you see on trestles and tables behind the aircraft here are all going to be painted off the aircraft and then put on the aircraft once it's all painted and dry. That means that every face can be inspected and repainted, so when it goes back together again you won't be able to see any bare aluminium. It will all be encased in the protective paint. All the turrets are currently off the aircraft, they'll go back on after it's been repainted. The aircraft will come off its trestles and jacks around the 3rd of April, and it'll be lowered back onto its wheels. So the painters have got from the 20th of March through to the very latest, the 3rd of April, to get the aircraft finished. And we've got to have it all bolted back together again, engine tested and run, taxi tested and taxied before the 29th of April. So it's quite a short turnaround for us. Various things we've done this winter which we've never done before. We've removed the tail oleo for the tail wheel. That's been out and inspected to make sure that's okay. We've also removed the number 1 fuel tanks. They fit between the fuselage and the undercarriage. So they, we believe, haven't been dropped out of the aircraft since about 1952, 1953. That's the inspection stamp on the tank anyway. So removing those has enabled us to have a good look at the spars in there, have a look at the area around it. The majority of corrosion things we've found on the aircraft really are due to it being steel, which means it's rusted, or steel placed against aluminium, which means you get something called dissimilar corrosion, where the two metals fight each other and corrode against each other. So you'll see on the port side of the nose of the aircraft, there's 2 or 3 patches which are now yellow and been treated. They are basically where steel parts have reacted with the aluminium and we've had to put a patch repair in place. There's also various skins on the aircraft that have just had to be replaced due to the level of corrosion on them. So 2 here, as I've said, behind the undercarriage, and another 2 on the starboard side. Other than that, really, there's not been too many skins we've had to replace because of the corrosion on the aircraft. There's one on the wingtip you see behind you. There's a yellow skin been placed there, and again that's due to dissimilar corrosion. The tip of the wingtip there is actually steel. It's got a steel cap around it to protect it against anti-aircraft wires, basically balloon wires and things, cables. So that wingtip leading edge has corroded the panel it's attached to. So there's various things on the aircraft where we've suffered from that, and basically just because of the age of the aircraft leads to the skin corrosion that we found on it. The way we deal with the skin corrosion, as I said, is to use those roll-lock discs to remove the corrosion. We then have to test the thickness of the material that's left behind to see if it's thick enough to be able to go again, or if that skin has to be replaced. But the survey we've done will tell us all that. All the survey we've brought together and produced in the survey pack at the end of this winter, so that when we do the work the following years, we can refer back to the pack, find out the condition of the item we're going to do, and then raise all the work and parts that we need in order to complete the project. So yeah, that's kind of where we are. The paint goes on, I said, 20th of March for about a week. It's going to be painted back in its Just Jane colours, so it will be black and camouflage, wartime Lancaster. It will have Just Jane on the nose as it did before. This side will be LEH, squadron codes, the other side will be DXF. So yeah, just as it rolled in the hangar in October, it will be rolling out in April. Just look a little bit. Something that may cause an issue is a spar on the aircraft. So a Lancaster spar, different parts of it are hours to different lifing. So the bottom rear spar on the Lancaster is lifed at about 4,500 flying hours. Another part of the spar's at 12,000, another part of the spar's 6,500, another part's 8,000. This aircraft has flown 2,424 flying hours. So officially there's a lot of life left on the spar. But if we find corrosion in different places of different depths, it may be dictated by the CAA that we have to replace that spar. The beauty of the spar, I guess, is the fact that it's got 4 booms in many sections. So if you find corrosion on a boom, you just replace that part of the boom rather than having to replace the entire spar of the aircraft. If you find any corrosion we find on the spar, you have to work out what depth of material you've lost out of that spar to then do the stress calculations to find out if that spar is actually still okay, and you just limit the amount of G and your all-up weight, or if you decide you have to completely replace that piece of spar. That's something that the CAA would also dictate to us. It's something the CAA are very hot on with this aircraft, is what the spars are like. The spar is basically the backbone to the aircraft. The engines are bolted to it, obviously all the wings are bolted to it, the undercarriage is bolted to it. It's where the main strength is, wingtip to wingtip. So that the CAA can't afford for anything to be wrong or weak with the spar. Obviously it's going to be flying a few hours in the year. But yeah, really, other than the surface corrosion we found, the spars will dictate how long the project will take, if it's accomplishable, and therefore how much it's going to cost as well. So that £3.5 million budget is allowing a certain amount towards a respar, but if all 4 booms of the spar, wingtip to wingtip, have to be replaced, then that's going to push us over budget. We do have all the jigs that we need in order to replace the spar. So the central section between the transportation joints will come off. It goes on a jig, the outer wings come off. The spars are basically drawn out one end to the other. The new ones copy drilled, put in, bolted together and finished. It's a lot more detailed than that, but that's basically how it is. So yeah, those are the kinds of things that could make the project pause or take a bit longer and a bit more expensive than expected. It would always operate from here. The Lancaster officially needs 5,500 feet to operate from. That is measured by the length of runway it would require to get up to takeoff speed and come to a trundling stop without brakes. For Lancaster, that's deemed to be 5,500 feet. There's enough length of grass strip that we can lay to do that on. So about 6,000 feet of grass strip that we can lay in a slightly different direction to our current grass strip. Take as many photos as you like, make the most of the opportunity because you may never see the Lancaster stripped down like this again. So please do take as many photos as you like, ask as many questions of myself and Martin until we walk away. Yeah, enjoy yourselves, take advantage of it. Thank you very much, thank you for coming.